For our third project, we're going to take all the concepts we've learned so far and apply them to a new type of game, a side-scrolling space shooter. And we'll add multiple new techniques for us to be able to handle and deal with different variations along the way. And if I just go ahead and start a new game here, we'll see that now our players are having to keep track of a lot more things as they play through the game, and they're having to deal with more stuff. And it makes the game feel more alive and makes the game feel more like an actual interactive thing and more fun for our players to play. So we'll deal with creating different waves of enemies, different enemy types, different objects for us to encounter along the way, shields for the player, weapons to fire, and then finally at the end of a level we'll add a boss battle for our players to deal with, that they have to work out how to destroy various parts to save the world. So we've seen the game in action, let's go ahead and start building it. Okay, so we're going to start our new project the same as we've done before. We're going to name it Alien Hunter. We want to make sure we set it to 2D, and we obviously have to pick a place to save it wherever you want to on your own computer. And I'm going to hit the Create Project button. And while this is loading up, I'm going to do the exact same thing we've done before, where we're going to create some default folders for us to use to start the game out with. So we're going to go into our Assets folder here. We're going to create some new folders. We're going to create an Art folder. I'm going to create a new Audio folder. We're going to create a folder for Materials. Create a folder for Prefabs. One for Scenes. And one for Scripts. So these are kind of the basic folders that I would always set up when I'm starting a new project. So regardless of whatever I'm going to be doing, these kind of 6 basics kind of cover a lot of stuff that you will generally do when making your own game. So we've got all our folders set up. Next thing we're going to do is bring in some art files. So we've got the included resources folder for our project. So I'm going to grab these 4 art files and pop them in to the game here. Let them compile and load in. And then once they're all loaded in, we're going to do much like we did on our previous project, and we're going to split up this sprite sheet here into multiple different pieces, and this is what we're going to use for all the various different components of our little game here. So we're going to go to over here on the inspector when we have our image selected. We're going to go to sprite mode and set that to be multiple. We're going to set our pixels per unit down to 64. And we want to do a couple of other little things. We want to set the filter mode to be point, and then down on max size, because it's 256 by 256, we're going to set 256 as the max size, and a compression at none, so we don't get any weird artifacts in our images. So we're going to hit apply there, and we're going to open our sprite editor. And now what we could do is go ahead and draw around any of the individual sprites that we want to use as we're making our game, but instead what we're going to do is make it automatically chop up this sheet into all the various different pieces. So each piece has a little bit of space around it, so Unity knows, okay, if something has a bit of space around whatever is drawn on the sheet, then it knows, okay, I should select that as an individual object. And the way we can do that is to go up here to Slice and set it on type here. We want to set it as automatic. So there's some other options you can do it to chop up by a specific size of individual boxes basically on the sprite sheet, but we want to do it by automatic, so it'll just choose whatever ones it can, and then we just hit the slice button, and you see straight away it draws a little box around every individual object on the screen, which is perfect. That's exactly what we want to do. So we're going to hit apply here now, and it'll apply all them into the game. And then if we hit the little right arrow beside our Alien Hunter's image, we have all of these various different pieces laid out for us now. So I'm going to click and drag this spaceship into our scene, and that's going to act as our player. So I'm going to rename him as player, like that. And there's one more thing we're going to do, as we've done in our previous project. We want to make sure that our camera is set up as 16 by 9, so that we're keeping everybody seeing the same thing. So we set it as 16 by 9, and then we know that our players have a certain amount of area to move around in. So now that we've got our spaceship in place for the player, let's start moving them around within the world. Now in our previous game, what we used to move around was on our paddle, we just changed the position of the paddle within the world. And what we used to move the ball around was rigid body forces. But we didn't actually control the ball. We just started it moving with some forces and it went flying off in whatever direction it wanted to. But what we're actually going to do in this game is use the rigid body forces to move the player around the world, rather than controlling specifically where it is in the world itself. They're both perfectly fine options for how to move your player around in the world. They just do some different things with how Unity handles physics, basically. So, to do that, obviously we're going to need to add a rigid body to our player. So we're going to go add component, and we're going to add a rigid body 2D. But also, in order to use a rigid body 2D, it needs to have a box collider to attach to it. So we're going to go to add component. Well, it doesn't need a box collider specifically, sorry. It needs a collider of some kind. But we're going to use a basic just box collider 2D for this object. Now our box is very big, and what could end up happening in the future when we have enemies that will shoot at our player, if they manage to hit kind of this area here when our player is moving down, if they hit the box here, then our player will take damage, but visually it won't look like they should have taken damage. So what we actually want to do, and what's a very common thing to do in these kind of games, is actually make the box a lot smaller than you would logically think it should be. So I'm going to shrink it down on the x-axis here by clicking on the x and dragging to the left. And you'll see our box gets a lot thinner, like that. And then I'm going to move it to the side by going to offset here and clicking and dragging to the left and moving it back a bit. And see now it's a little bit shorter than the ship, but it's still as wide as the ship. But that's too wide still. We want to shorten it down a bit. So I'm going to grab the Y size and pull that down a little bit, just so it goes inside the ship. So this area here is actually the full area that enemies can hit. And it adds, it makes the game feel better to the players. So rather than using the full size of whatever object you're using to fly around in, just using this slight bit smaller just improves immensely how the game actually plays. Okay, so with that all done, we have a rigid body, we have our box collider. Let's go ahead and create a script to let our player be able to move around. So we're going to go in here into our scripts folder and create a new C# script that we're going to call our player controller. And we'll open this up in MonoDevelop. So once this is opened up, let's first of all give ourselves a variable to play around with, which is how fast our player is actually going to move. So we'll say public float move speed. And as we said, we're going to move the player around using the rigid body. So if we're going to use the rigid body, let's go ahead and make a reference to that. So we'll say private rigid body, we'll say DRB for the rigid body. And of course we know that if we want to be able to access the rigid body that's attached to the same object that this player controller script is, so this script obviously will be attached to our ship, and our rigid body is attached to the ship. Actually, this would be a rigid body 2D. But if we want to be able to access that rigid body, we know in the start function we have to say, okay, the rigid body that we just created should be equal to get component rigid body 2D. So that way it finds the rigid body that's attached to the same object that this script is. So perfect, now we're able to access that rigid body. So how do we make the player move within the world? Well, obviously we want to get whatever input the player playing the game is putting onto the objects. So what we could do is, as we've done previously, we set up specific keys to move up and down or left and right. But what we're going to use is actually something built into Unity that we can take advantage of that makes it a lot easier to take input in the game. So if I pop back into Unity here and if you go to edit and then down to project settings and then to input up here, you'll have this drop down over here on the right. It might be collapsed when you open it first, so you might just have axes, but just hit the little triangle to the side and then you see you get a bunch of different input options here. So we have horizontal, and that's movement on the horizontal axis, so that's moving along the x-axis left to right. We have vertical, which is moving up and down on the y-axis. Then we have some fire buttons, so that's different buttons to press to do whatever various effects you want to do. Then you can keep track of the position of the mouse on the screen, all various different stuff you can actually do within Unity. But you'll notice that we've got two horizontals here set up. And the reason for that is if I drop down this horizontal, what this is doing is actually checking if anybody presses the left or the right arrow, Or it's also checking if anybody presses A or D, which are the kind of common keyboard controls for moving left and right. And if we go down to horizontal here, what this one is doing is it's checking the joystick axis. So what it's actually checking is if there's a controller being used. So if we take advantage of using the horizontal input axis here, what that means is if we can allow players to control the game in a variety of different ways. They can control our ship using the arrows, they can control the ship using WASD, or they can potentially control the ship with a controller plugged into their computer. And it's good to give our players these options in different ways of being able to interact with the game. So we're going to use the horizontal axis, and the way we do that is, just as an example here, we're going to say, to access any kind of axis, we would say input dot get axis, and then in the bracket we just say horizontal. So we want to be able to check what input is happening on the x-axis, so making our ship move left to right. So I'm just going to delete that for a second, and we're going to decide how we're actually going to use this in our game. So the way we can do is say, okay, we can get input on the horizontal axis, which would be our x-axis. We can also get input on our vertical axis, which would be on the y-axis. So let's create a new variable, a new vector2 variable that will hold the x and y value for what input our players are currently given. So let's go up here below our move speed, and we're going to create a new public vector2 that we'll call move input. And then at the start of our update loop, the first thing we're going to do is just say, okay, that move input we just created, move input equals a new vector2, and on the x-axis we wanted to take the horizontal input that we have over here, so we'll say input dot get axis horizontal, oh, not horizontal, horizontal, like that. And then on the y-axis we'll have it say input dot get axis vertical. So we see here we have the vertical axis, and that will allow us now to be able to take input from our players pressing up and down for vertical, or W and S, or moving the analog stick on a controller up and down. And the same for our left and right, we'll be able to move left and right and all like that. So now we're getting any input that the player is creating for our game. So let's use that input to apply some force to our rigid body. So we know if we want to use the velocity of our ship on a rigid body, we just say the rigid body dot velocity should be equal to, and what we can set it to is, we know we're going to use this move input vector2, which is taking in whatever input our player is currently pressing. So we'll say move input, and we'll just multiply that by whatever our move speed is, so how fast we want to move the ship around in the world. So let's save that and pop back into the game and see how this will work. We'll let it compile here, and we of course need to actually attach the script to the player. And once it's finished compiling, we can go down here. We're going to add this new component, our player controller. We'll give him a move speed of say 5, and we should actually make our move input private because we don't need to see that value when we're playing our game, but just for interest's sake we'll show it here while we play the game first time. And we hit press play, and now we'll see, oh well, our ship is slowly falling down because we didn't turn off our gravity scale, so I'll just do that here. But now we'll see our ship can move around within the game. And now before we go any further, we're going to have the first kind of question of game feel about our game. So if you notice the numbers on the right, so I'm not pressing anything now, and I'm going to press the button to move to the right, and you watch the Y value. So if I press the button, or sorry, watch the X value, it was the wrong one, sorry. So again, we'll just start here. So we'll watch the X value here, and we go to 1, and then it slowly goes back to 0. And what you'll notice if you watch the ship moving, as soon as you start moving, there's a little bit of a lag before the ship kind of gets going. And that's due to how we've set up our input.get axis. So I'm just going to stop this game running here. I'm going to remember to turn the gravity back off again. So set it to 0. I'm going to go back into Unity here. And so what we've used is input.getAxis horizontal. And what this does is it basically kind of gradually moves between whatever the previous input was and whatever it currently is. And we might not necessarily want to do that. It depends on how you want your game to feel. If you like that kind of delayed kind of input and a little bit of lag, it can change how the game feels, and it can make a difference to how your game particularly feels. But if you wanted it to be very specific and it matched to exactly what the player is inputting, what you want to do is say, instead of saying input.getAxis, we want to say input.getAxis raw. And input.getAxis raw means that it'll just put out exactly what's being pressed right now. If we just use input.getAxis, it tries to kind of blend between either 0 when you're pressing nothing or 1 when a button is being pressed, and it'll kind of smoothly go between those two numbers. But getAxis raw will just go straight away from 0 to 1. So let's save this and go back into the game and see that in action. We let it compile. Let it go for a second. There we go. Now we press play. So this time keep an eye on the x-axis again, and at the moment it's 0. If I press the button, straight away it just goes to 1. And you can see now on our screen the ship is moving exactly with how I press. There's no delay, there's no like little boosts as it goes and kind of a feeling of weight, but you get a much more sense of control. So you're kind of sacrificing, hey, if we do the other way, our ship kind of feels like it has a bit of weight and momentum, but if we do it this way, we have very specific and tight control to the game. So as I said, it's all down to personal preference and how you want your game to feel. So feel free to either use getAxis raw or just getAxis. So now that we have our player moving around, there's one other little thing we want to fix up, which is that at the moment we can make our player just fly off the screen, which obviously is no good. So we want to make sure that our player can not go off the screen on the left and the right, or at the top and the bottom. Now in our previous game, where we've been controlling paddles, we haven't wanted them to go off the screen either, so we set up a very simple way of checking if our ship goes above a certain value, make sure that it gets set back to being exactly that value. And we could do the exact same thing with our ship here and just check if it goes above this point, then set it back to here, or if it goes below this point, set it to here, or if it goes left of this point, set it back to here, or if it goes right of this point, set it back to here. But then we're ending up with 4 different if statements there, when what we can use is a different technique that's built into Unity that we can take advantage of and make it much simpler for us to be able to control. So to do this, we're going to need 2 different points in space. So we're going to have somewhere that it can go most to the left here and most to the top value. And then over here we're going to have another point in space where it can go most to the right and most to the bottom. So let's create those 2 objects first of all. So we're going to create a new empty, and we're going to say top left for this one, and I'll move it into position in a second. And then we're going to create another one and call this one bottom right. And we want to make sure that our ship can actually go to these positions. So the first thing I'm going to do is make both of these a child of the player, and then set both of their position to be 0, 0, so that they're exactly on top of the player ship. And I'm going to move our player ship up to the left corner of the screen, so up here. So this is as far up as we want our player to go here, and as far to the left as we want him to go as well. And if we go to our game view, we can see that's as far up as we would want our ship to be able to move to. So that's fine. So that's where we want our top left to be. And now, because our top left is a child of the player and we move the player, our top left is exactly where the player should be. So let's make it no longer a child of the player. And now there's no longer a child, it'll stay right there. But if we move the player out of the way, like down here, our top left will still remain there, so we know that we can say, okay, that's exactly as much as we want the player to go to. So let's do the same now for the bottom right. We'll move our player down to the bottom right here. And we probably don't really want our player to go too far right on the screen. So we can actually pull it back a little bit to allow space for any enemies to kind of appear here and not just completely destroy the player as soon as they encounter them. So now that we have our bottom right position, I'm going to drag that out, and it's no longer a child of the player at all. and we go back to our player. So now let's set these up on the player controller script so that they're actually going to do something. So we'll go back into our player controller script and we'll create a reference to both of these objects. And we'll say, we'll create a public transform, and this one we'll call top left. And we'll create another public transform that we'll call bottom right. And now the thing that we're going to use for controlling our player's movement is a thing called a clamp. And a clamp basically says, I'm going to make sure that whatever value you put into me will stay between two other given values. So the way we can use this is to say, okay, the position of our player ship, so the transform dot position, we want to set that to be a new vector tree, because remember, transforms on every object have an x, y, and a z value. Even though we're using 2D for everything here, we still have to account for the z value of every object in Unity. So on the x-axis, what we want to say is matf dot clamp, and this is our clamp function that will allow us to control the position of the object within the world. So within this clamp, we have a float value, a float min, and a float max. So the value is whatever we want to pass in. So for example, that's going to be our current position of our ship, wherever that is on the x-axis. Then we want to say a minimum value on the x-axis that it can possibly go to, which will be the x part of our top left. And then we want to set the maximum value, which will be the x part of our bottom right. So here we can just say, okay, the first value is where we currently are. So that's our transform dot position dot x. Then the next part is what's the minimum value. So that's on our top left object. We know that's as far left as we can go. So we can say, okay, on the top left, on the x-axis, that's as much as we want to go there. And then the maximum value is going to be, okay, on the bottom right, that's as far as we can go to the right. So that'll be our x-axis there. So that's our bottom right dot x. So that's perfect. We've got our clamp set up on our x-axis. So we'll do the same on our y-axis now. We'll say matf dot clamp, and here we'll say, okay, the value we want to use here is wherever we currently are on the y-axis. So transform dot position dot y. The maximum we want, or sorry, no, the minimum we want to go to is wherever is our y value on the bottom right object. So we'll say, okay, bottom right dot y, and then finally the maximum we want to go to is on our top left object, wherever the y is on that. So we'll say top left dot y, and we'll close that bracket and hit a comma, and then we need to decide where we go on the z-axis. And as usual, we don't want to change what's happening with the z-axis at all, so we'll just say transform dot position dot z, like that. So perfect. Now we're constraining the movement of our objects within the world. Oh, I actually just realized these should be not just top left dot x, they should be top left dot position dot x, because of course it's a transform object, so it has a position, a rotation, and a scale. So they should be top left dot position dot x, bottom right dot position dot x, and the same for our y's, bottom right dot position dot y, and top left dot position dot y. Okay, perfect. We'll save this, go back into our game, and what we should have now is our player being restricted to moving within this given area on the screen. Of course, we need to actually set up these references to work properly with our player. So once it's compiled, we'll scroll down, we'll move top left into the top left slot and bottom right into the bottom right slot. We'll hit play here, and now we can move our ship only over to the right here. We can't go off the screen at the top, we can not go off the screen on the right or on the left even, and we can't go off at the bottom. But we're free to move around in this area completely, but then if our players try to go off the screen, they won't be able to, and we're able to stay within our playable area. So perfect, that's exactly how we want it to work. So with our player now clamped to the screen, we can add something that will make our player look a little bit more interesting, which is a bit of a jet flame coming out of the back of the ship. So we're just going to go into our little art assets here, and we're going to grab one of these. I'm going to grab, there's 3 different flames here, I'm going to grab the shortest one, which should be the first one in our list, and we go back to our scene, and I'm going to drop it into the world here, and I'm just going to rename this to be our jet flame, and I'll move it into position just behind our ship like this. There we go. And I'm going to click and drag this onto the player. So now it's, if we click off it, you can see it's actually, no, we don't want it overlapping with the player. We'll put it kind of out the back a little bit like that. So that's all fine and dandy. It's kind of hanging out there like that. Perfect. And now if we were to move around in the game, we look like we have a bit of a jet trail going behind us. But at the same time, it kind of looks a bit bland. It's just this static little thing. So let's add a little bit of animation to our jet flame. Now we haven't done any animation yet in this project or in this course, but animation is relatively simple to do in Unity, especially when you're dealing with sprite animation. All we have to do first of all is open our animation window. So go up to window up here, and we'll scroll down here to where we have animation, and this will pop open a new tab, and I'm going to click and drag this tab so it docks in between our project and our console windows here. And then on animation, the first thing we need to do, if we're going to animate this jet flame, we need to go to create an animator for it. So we just hit the create button, and that will allow us to create an animator, or it'll automatically create an animator for it, but we need to create a specific animation that we're going to use for our jet flame. So we're going to use an animation that we'll just call this our jet flame animation, because there's not going to be anything else to it. But where we want to save it, rather than saving it in this art folder, we're going to go back up to our assets, and we're going to show this is another way to add folders into the game. We're going to add a new folder through the interface here, and we're going to call this animations. So we'll save this in this animations folder. We can hit save, and if we go back to our project view, we'll see now we have a new folder in our assets that is where we're going to save all our animations in general. And you can see we have this jet flame animation that we just created, although at the moment it's not doing anything, and this is the animator that will control, or sorry, it's the controller that will control the animator that makes all our animations work. And we'll dive into that when we start doing a little bit more animation, but for now we can just ignore that and deal with specifically the animation we're doing for our jet flame. So let's go back and make sure we have our jet flame active in the window here, and we go to the animation window, and we see we have a timeline here of how animations will work. So at the moment there's no animation going on because we just have this one image. So what we're going to do is drag other images into our timeline that will make the animation kind of flow and happen. So to do that, we're going to go to our project folder here, and what we want to do is click and drag images onto our animation window. But at the moment, of course, we can't see anything because our project and our animation window are both on the same kind of a row of tabs here. And what I like to do personally when I'm doing this stuff is I just grab my project window and just pop it over where our game view is, or sorry, not over where our game view, where our scene view is. And actually, to make it a little bit more easy to see, we kind of want to be able to see our scene view as we're doing this. So what I'm going to do is now drag it down below and slightly over to the side, and what that does is it creates a whole new section here that we can use to see our images. So now I can just scroll down through all the various different objects. So we already have our small little flame in place, but because we want to use an animation, we need to make sure that the first frame of our animation will actually use that small frame. So I'm going to click and drag that small bit of flame into the scene here, and it'll pop it in there. And you'll see it creates this little diamond shape, and that means it's a keyframe of animation, so that Unity knows, okay, at this point in the timeline, this image should be here. So we're going to move on one frame to the very next frame, and I'm going to scroll down here and find the next size up of our flame and click and drop that in there like that. Then we're going to move on to the next frame again and grab the biggest flame and pop that in there. And then we're going to move on one more frame and go back up to the middle flame and pop that there. So what's happening now is it's going small, middle, large, and then what it'll do, it'll go to middle again, and then finally it'll loop back around and go back to the very start again. So it'll play through this little sequence, and if we click and drag along the timeline and look up here, you can see the size of our flame looks like it's growing and shrinking as we go back and forward. So now if we hit the play button over here, we can see, hey, our jet engine is kind of growing and shrinking like crazy. It's going really, really fast. It's going probably too fast for our needs and for our desires. So there's two options of what we could do. We could go and we could just stop this plane, and we could stretch out these keyframes and make them be further out, or we could change the sample rate. So at the moment it's saying it's running at 60 frames a second. We can slow that down to say 12 frames a second, which means now there's a much bigger gap between our frames here. So if we hit the play button, it's not being resized. Just let me click off and we click back. Sometimes Unity is a bit weird with this stuff. If we turn this off here. Okay, yeah, there we go. So the way to fix that little bit of an error, it just took a couple of seconds to sort it out there, is if you just add a blank keyframe in there and then undo it, it'll adjust the timeline to be the right length. So that's kind of just a strange little bug here in Unity that shouldn't normally happen, but if that happens in your own project as we're working here, that's how you can fix that. So just go to the next frame, add an empty keyframe and undo it, and it should fix the problem. Okay, so we have it back on 12 frames. So now we can see, hey, that flame, it looks like it's growing and shrinking in a kind of reasonable way. So let's see that in action in the game. But when we're done animating, it's important to remember, always untick the record button here, because if we were to leave this here and let it keep recording any changes we make, basically what can happen is, if for example I go ahead and move this jet flame now, that's been added to the timeline. So now our animation is this jet flame moving around like crazy in the world, and that's no good. We do not want that to happen. So I'm going to undo that and make sure that that isn't saved, and I'm going to turn off record, and now I can feel free to move this jet flame wherever I want, and it'll just play the animation in whatever that place is. So I'll turn this back off again, we'll undo it, move it back to the right position. But let's play the game and see how that looks. So at the moment now, our jet flame animation is working. It's a bit small there, so let's maximize this. You can see our jet flame is working the way it should be, but it's kind of growing and shrinking into the body of the ship, and that kind of looks weird, and that's not very good. So let's fix that. So we've done with this little bit of animation, so I'm going to move this project window back where it should be. And the reason why it's growing and shrinking both on the left and the right is because it has a center point. All our jet flame sprites have a center point right in the middle of them, and we can actually move that center point when we are editing it in the sprite editor. So if we go back to the main sprite sheet that we have for all our images, and we go into the sprite editor here, if we go to each one of these jet flame objects on the left here, we can set the pivot point, instead of being the center, to be on the right, like this. There we go, all three of them. Okay, so we'll apply those changes, go back into Unity, and you'll see that now the jet flame is suddenly way more over to the left, and that's because the center point of the whole entire object is now at the very tip of the flame. And because we moved it into position with the understanding that the center point of it was kind of here, now it's moved over to the side a little bit. So we can just grab our jet flame and we'll put it back in to be closer to the ship. And now if we go back to animation and hit play, now it looks like our animation is stretching out behind the ship and kind of shooting away behind it as we go. And that's actually a little bit slow, so I'm going to speed this up a bit, like that. We're still getting this weird error with the... Okay, I think I've fixed the issue. It seems like the reason, or I don't really know what the reason is. It's as I said, it's a strange bug within Unity. But if you actually just click and drag the very last keyframe, so you drag it off to the right and then back to the left, Unity knows that, hey, this is where the last position of this should be. So now if I adjust the speed, nope, it didn't fix the problem, of course, because it's Unity and it's a bit weird about all these things. So let's just play the game and see if it actually works properly for us this time. There we go, now the animation is actually set up properly. So doing that seems to fix it at the correct frame rate, but Unity is a bit weird sometimes, so it can cause problems if we adjust it. So it's one of those little quirks of Unity. It's something you need to work around and pay attention to when you're creating your animations. But for now, you can see our jet flame is actually doing something, and now when we fly around, it actually feels a bit more sensible as we're going. But I'm feeling now the player is a little bit slow, so I might actually adjust the speed of the player here. Let's put it up to 10. Whoa, that's a bit too much. There we go. 7 feels a bit faster, so I'm going to stick with 7 for the movement speed of our ship, especially left and right. Just like that. Okay, perfect. So we've got our ship moving around just the way we want to, and we've got a bit of a jet plane, or jet flame coming out the back of it. But when we're moving our ship, at the moment, when we move up and down, it kind of looks a bit static. So let's add some animation to how our plane is moving to make it feel like it's a bit more alive and a bit more active. Okay, so we want to make our spaceship, not our plane, but we want to make it feel a bit more active as it's moving up and down. And to do that, basically we're going to make it look like when we're moving down, the ship is kind of banking to the right, or kind of tilting a little bit to the right. And when it's moving up, it's tilting a little bit to the left-hand side. So that's why we have these 2 other sprites down here. And to do this, we're going to use some animation to control how it looks when it's moving. So we're on the player at the moment. So we're going to go to our animation window and create a new animation here. So we're going to go into our animations folder, and we're going to say this first animation is player idle. And for player idle, basically we want to have it be the default player view. So to do that, we're going to drag our project window over to the right here, so we can see our project files and our scene view and our animation window all in the same place. And the reason we moved the the project window rather than the animation window is because we actually want to see a lot more of our timeline ahead of us here. So we want to be able to control what we can see in regards to those. So it makes much more sense to keep our animation on the bottom so we can see a lot more of it. So let's find our 3 bits of spaceship. So that's our 3 ship objects here. So the first one is going to be our player idle. So that's basically what it looks like when our player is in the default kind of standard position. So that's fine. We don't need to add any more animation to this because this is just going to be 1 frame constantly. It's not going to change at all. So let's add another animation. So we click on player idle here, and then we go to create a new clip. And we're going to create a clip called player up for our player moving up in the air. And that one is going to be using the 3rd sprite here. So you can see it's darker at the top, so it kind of looks like it's shifting, so it should be moving upwards. So I'm going to click and drag this onto our timeline like that. And then finally we have another clip for player down for our player moving downwards, and that'll use the other image, and we'll just drop that in there like that. Okay, so we have our 3 animations now, but we don't have any way of actually telling our game which animations it should use. And to do that, we need to use the Animator window. So I'm just going to, first of all, click and drag our project back into view down here. Turn off our record view so we make sure we're not doing any other weird changes with that. And I'm going to go to window up here and go down here to Animator and open that up. And that'll open in our scene view, and that's fine. We don't need to worry too much about what we can see here. But what we'll see when we open our Animator is those 3 animations that we just created have all been added as blocks here in the Animator. So I'm just going to rearrange these a little bit. I'm just going to put the player idle there, and I'm going to put up above it and down below it. So this Animator view basically controls the logic of how it moves between different animations. And what we're going to say is, we're going to, in our player controller script, tell this Animator, okay, we're going to give it a value for when we move up and down. Say we're going to give it the value 1 when we should be going up, and we're going to give it -1 when we should be going down. And if we tell that information to the animator can then go, okay, when that particular number is at 1, go to the player up animation. When it goes back to 0, we go back to idle, and when it goes to -1, we go to player down. So let's set up the value we're going to use for that, and the value we'll use is, we'll go to parameters here, hit the little plus button, and we're going to use a float value, and the float value we'll just use movement for that. And then what we do is on player idle here, so player idle is marked as orange because it's the default state that we start off in. and it's the default state because if we hold right click, if we hold Alt and then click and move, we can move this window around a bit. And here we have entry. So entry is basically the start of any of the animations. So straight away it goes from entry. You can see we have this arrow that points to player idle. And then what we'll do is from the idle position we'll determine, okay, we should change to a different one. So we'll right click on player idle and say make transition, and then we don't hold and click, we just like let this arrow kind of move around with us, and then we click on player up here, and now we have this arrow going from player idle to player up. Let's move this over a bit more. And if we click on this arrow, this is called a transition, and we can make changes to this transition and the logic that it uses to go to player up. So what we can do is go to conditions down here and change the condition that we want to say if movement is greater than 0, but specifically we'll say if it's greater than 0.1, then change to being player up. And that's fine, that's exactly what we wanted to do, but there's a couple of other things we wanted to do that'll give us a little bit of an error. We won't set them up just yet, but we'll return to that in a minute because we'll see it in our game itself. So we've set it so that when our speed is greater than 0.1, we go to player up. So let's say if we're at player up, we want to make sure we can go back to player idle animation. So we'll make a transition back to it and say, okay, when our movement speed is less than 0.1, then we'll go back to player idle. And then when we're in player idle again, say we want to start moving down, if our movement speed here is less than minus 0.1, then we'll go to our players moving downwards, and we'll make the transition again back up to our player idle and say, okay, if our movement speed now is greater than minus 0.1. Okay, so those are our kind of basic values for all that set up, but now we need a way to actually tell the animator what the value is when our ship is moving. So let's go into our player controller script, and we're going to need to be able to interact with that animator object. And much like we saw with the jet flame, now when we created the animator, if we go to our project files, it created a player controller here in the animations folder, and it also on the player object, if we scroll down, it created an animator component that was automatically attached to the player. It did the same thing for our jet flame as well. It created an animator for that. But on our player now, it has the animator component, and you can see it has a controller attached to it, which is this player controller, and that's what we're viewing here in the animator window. So we know that we want to make some changes to this animator here, so we have the animator component attached to it. So if we're going to make changes to it, we know that we're going to need to have a reference to the animator. So we're going to have a private animator that we'll just call anim, and if we're going to get a component that's attached to the same object as the script, well, we know that we can do anim equals get component animator. So we're getting the animator component that's attached to our player ship object, and then what we'll do is just tell that animator object what our current movement is. So we can just say we're only really worried about our ship moving up and down, so we'll tell it what the movement is on the y-axis. So we'll just say, okay, on the animator, on the anim, we want to set a float value, and the float value we want to set is, if we go back in here, the movement value that we're using to control the change between these two different animations. So here we'll say, okay, the name of the float we want to set is movement, and again we want to make sure that's spelled the exact same and capitalized the exact same, and the value we want to send into it is whatever input we currently have on the y-axis. So that's the vertical axis, so we could say input.getAxis raw again, or we know that's been applied to our move input.y. So we can just say move input.y like that. And now that's sending the information into our animator so it knows how it's able to move. So we'll just let that save, go back into Unity and let it compile down below. We'll switch back over to our scene view and we'll hit play. And now we should see when we move up, our ship looks like it's turning and moving along with us. It's fine when we're moving backwards and forwards. We don't really need to have any kind of thing because our jet flame is kind of representing that we're moving with some force behind us. But if we're moving up and down now it looks like our ship is kind of active within the world and it's not just a flat object moving around. But you'll notice when we move up, there's a bit of a delay between our ship moving and the animation kind of happening. And that's because of how our transitions are set up in our animator. Like I said, at the time there was a bit of an error that we were doing and overlooking. And what that is we'll go to the first one we made here when we switch from player idle to player up. Basically we have this thing called an exit time, which is how long it takes to move between each animation. So if I hit this little drop down here, at the moment it's okay, well by default it managed to set the exit time as 0, but sometimes it won't do that. But we also have this transition duration of 0.25. So that means it takes 0.25 of a second to transfer between our idle animation and our player up animation. So what we want to do is we want to make sure our transition duration is set at 0, and we also want to turn off exit time because we don't want it to take a certain amount of time to exit. We'll also turn off fixed duration because we don't want it to take a certain amount of time to change between each one. So we'll do the same on all 4 of these different transitions. So we'll turn off exit time, turn off duration, and set duration to 0, just to make sure that we're kind of doubly making sure that we're not going to get any weird things going on. So we just need to make sure we do that with all our animations whenever we make a transition between them. The reason it's set up to do that is because if you're, say, using a 3D character, you want it to kind of smoothly go between different animations, nice and gradually. But because we're using sprite-based animation, we want it to instantly snap between one frame of animation and another. So that's why it's built into Unity that it adds this little bit of duration as we go, but we don't want that, so we need to make sure and disable that as we play through the game. Okay, so now we'll press play, and this time, as soon as I tap up, you instantly get the movement being applied. So now it feels a lot more immediate, a lot more like it's reacting to your input, and we can go ahead and keep playing the game. Okay, so now that our player can move around within the world just the way we want them to, let's give them somewhere to actually move around in that's a bit more interesting rather than this vaguely blue space. So the first thing we could do is just give them a kind of black background to make it kind of look a bit more spacey, but it's pretty empty. It's just kind of space boringness. That's not very good. So instead we're going to add a bit of a background art to the situation. So in our art folder, one of the files we imported was this kind of space texture. So I'm going to go to our scene view, scroll out a little bit, and click and drop this in here into the world. I'll make it a little bit bigger so that we can see it all. And now one of the problems, of course, we can see is if we switch to the game view, our spaceship disappeared. So to fix that, we can use the order in layer of the graphics of this. So on this object, if we look in the inspector, all we have over here is a sprite renderer, and we can change the position of how this appears in the screen. Basically by saying the order in layer here, we can say, okay, we want to set this to be -1 so that it appears behind the ship, which by default everything is put at 0 in this. So we'll actually set this to be -100 so it goes behind any other objects we might want to appear in the scene as well. So that's fine, now we have that there, and if we hit play in our game, we have this bit of space behind us that we can move around in. And that's all fine and dandy. We could have that there and we could have enemies coming in from the side, but we want to make it look like we're actually traveling through space as we go, because if we just kind of stay here like this, it just looks like, hey, our spaceship is just kind of staying there still. That's not very interesting. So we're going to make it so that this background will actually start scrolling behind the player. But to do that, we can't actually do it with just this basic sprite that we've dropped into the world. We have to use textures, which are another thing built into Unity. So I'm going to delete this one that we have here. What we need to do is go into our materials folder, and we're going to create a new texture here. So we're going to create a new material texture, and we'll call this, we'll just call this background, like that. And we want to apply the image that we used, that we have in our art folder, to our material that we just created. But to be able to apply it, we can't just leave it as this basic sprite that we have. We actually have to go and change our texture type here to be default, so that we're just a kind of normal texture that you wouldn't use on like 3D objects in a game. And what we'll do is go down to wrap mode here and set it to repeat, so that we can constantly make this same image loop around as it moves. So we'll apply those changes there. And then we'll go back to our materials, this new background material we created, and we're going to go to, which one is it now? We want to do a standard, there we go. We go to legacy and diffuse, we want to keep it nice and simple and nice and basic, and here we can select a texture to use, and we're going to select that space kind of background that we created as a texture, and now we can use that to apply to objects within our world. So to apply it into something in our world, we need to use a 3D object that we can apply it to, but we're actually going to apply it to not just a 3D object, but a flat 3D object. So we're just going to go to game object up here, and we're going to go to 3D objects, and we're going to create a plane, which is technically just a flat object. So at the moment it doesn't have anything that we can see, but what we want to do is, because we're in a 2D view, we can actually see where our plane is. So we're actually going to grab it on the x-axis and rotate it like this, and you'll see suddenly it comes into view and we can see it, and we actually want to set our rotation to be -90. So it creates it as this perfectly square object in the world. It gives it an orange outline just so we can see it when it's selected. If we click off, it gets disabled. So let's go back into our plane, and we're going to stretch this out so it's wider than the camera and just a little bit taller than the camera. We don't need it to be square, we're not too worried about that. And now what we can do is click and drag our material we created and just pop it on top of our background plane. And now if we switch to our game view, we have our background space view available to us, and that's all fine and dandy. But now we need to make it so that it actually scrolls along behind it, and to do that we're going to need to create a new script. So we're going to go into our script folder and create a new C# script that we will call our scroll background script. So we'll open this up in MonoDevelop, and very simply all it's going to do is we're going to give it a value of speed of how fast it should move, and it's going to just constantly move that little image in the background a little bit every frame. So to do that, we're going to say, okay, we need to move this object by a certain amount of speed. So we'll say public float scroll speed. So that'll be how quickly it moves. But if we're going to move it, if we go back into the game and look at our plane, so the thing that actually makes this appear to us so that it's a visible object is the mesh renderer. So the mesh renderer is what shows the object to us, and we want to be able to access that so that we can move the image along to the side as we're going. So we'll go back into our MonoDevelop script, and we'll say, okay, we want to access that, so we want to access our renderer that's attached to us that we'll just call it rend to keep it nice and simple. So we want to access the renderer component, which is our mesh renderer here. It's just called renderer rather than mesh renderer. So to access that component, we know that we want to say in our start function, okay, rend should be equal to get component renderer. Perfect. So now we have access to that component. So down here in our update, what we're going to do is create a new float value. So we're going to say float here that we're going to call offset. So offset is going to be how much we want our background to move by, and the way we work that out is by taking time.time, so that is the time at the beginning of this frame, so it's how many time since the start of the game has gone, and we're going to multiply that by minus scroll speed. Nope, I spelled that wrong. So we're going to multiply that by minus whatever our speed is that we set it as. And the reason we do that is it's kind of complicated behind why that works with Unity. It's just one of the weird kind of quirks of how it works in the game. The only thing to really know is basically that this works. You can kind of fiddle around with it and you can play with the values yourself and see how they affect the texture when we apply it to the game. But you basically, all you really need to know is that this is the simple bit of code that will allow us to work out how much our background will move within the game. So then we will apply that to our renderer. So on our renderer, we will access the material, which is what shows us the background object, and we were going to set texture offset. So we're setting the offset of the texture. So we want to tell the texture that we're offsetting is main text. So again, that's just the default thing within Unity that lets Unity know, okay, the texture that we want to kind of move off to the side a little bit is the texture that is being applied to the background object. So we're moving main text, and the amount we want to move it is a new vector2, because we can only move it on the X and Y axis, and we want to move it on the X axis because we know we want to look like we're traveling through space really fast. So we'll say new vector2 offset on the X axis, and on the Y axis we don't want it to move at all. We don't want it to scroll up and down at all. So we'll save that and go back into our game. Working with textures like this can be a bit kind of confusing at times. That's why we don't really want to delve into the details of how specifically the mesh render and things like that works. At the moment, you don't really need to know how the details of this works, because it's just overcomplicated stuff. As you go deeper into Unity, you can learn it as you go, but at the moment all you really need to know is that this simple little bit of code will easily make our background move for us. So now we can apply that script to our plane here. So let's apply the scroll background script. I'm just going to set the scroll speed to be 1. I'm going to change actually the name of this plane here to be BG, so we know it's the background. And now we can press play here, and what we should get, we get our space flying along behind us. So it looks like now our ship is flying along through space and encountering new amazing things as we go. So that's all fine and dandy, but this is probably a little bit too fast. In fact, what we want to do is slow it down quite a lot, because if our player is going that fast through the game, it kind of overwhelms everything, and you don't really have the ability to keep track of what's going on. So I'm going to set this to be actually 0.05, which might seem like a lot, but it makes it a lot more manageable of this scroll here. So there we go. Now we're kind of gently going through space. When enemies come in, it'll look more active and look a little bit more interesting to the player. So there you go. That's how we can set a nice little scrolling background in our game. So let's move on to actually adding obstacles for our player to interact with. Now that our player is moving forward through space, let's give him some stuff to actually make him encounter along the way. So what we're going to add first of all is just a basic little obstacle and make it kind of look like it's coming towards the player, and that is, if we go into our art file here, we're going to add one of these little asteroids into the scene. So I'm just going to grab this first one. Oh, we need to go to our scene view. I'm going to drop that into place there. It's perfectly fine the size it is, but I'll kind of just drag it up and make it a little bit bigger. And then on this object, we're going to give it a box collider, so it's physically in the world. Actually, no, we won't give it a box collider. We'll give it a circle collider, so that it's physically there within the world and can interact with the player. That circle by default is kind of, it tries to approximate the size of the sprite that we have, but that's a little bit too big, so we'll make this smaller here by clicking on radius and dragging it down just a little bit there like that. So that's perfect. The next thing we'll do is give it a rigid body for us to be able to apply some force to it and move it around in the world. So we're going to go to rigid body 2D here. And we don't want gravity to affect this. We don't want it to be pulled down as we go. So we'll set gravity scale to be 0. And now that we have this object here in the world, what we want to do is give it the ability to move around within the game. So we're going to go and create a new script first. So we'll go to our script folder and create a new C# script that we'll just call basic move. And nice and straightforwardly, this is going to be the basic amount of movement we want to give the player, or give any objects within the world that are coming towards the player. And nice and simply, all this is going to do is move our asteroid from right to left along the screen. So we'll give it the ability to move. So we'll say we need a speed for it to move at, so that'll be public float move speed, like that. And then if we want to be able to move this object using the rigid body that we just added to it, we need to access that rigid body. So we'll say private rigid body 2D, that we'll call DRB, and as we've done many times now, we'll say in the start function the rigid body is equal to get component rigid body 2D, like that. And then in our update loop, all we're going to do is adjust the velocity of it. So here we'll just say the rigid body dot velocity is equal to new vector 2, no, I can't spell, vector 2, there we go, new vector 2, and on the x-axis we're going to make it move, so that'll be our move speed, and we're not going to make it move on the y-axis, so we won't make any changes, or actually we'll specifically say it has no force on the y-axis there. So there we go, that's our very simple and basic movement of our asteroid. So let's go back into the game and set that all up. So we have our asteroid here. Let's rename this to be an asteroid as well, because at the moment it's just got this weird long name that's not very intuitive at all. So we'll say asteroid, and then down here we'll add that script we just created, which is our basic move script. We'll set its move speed at, say, 5, should be okay. Actually no, sorry, we want to set it to be -5 because we want to make this object move to the left rather than move off to the right. So we'll just drag it off the screen here. We'll hit play, and as soon as our game starts, there you go, our object kind of comes flying in, hits our ship, and kind of makes us go a little bit crazy, which we don't really want it to do. It's probably moving a little bit fast at the moment, so we'll actually slow that to be that should be -2. -2. Next thing we want to do is our ship. We don't want it getting hit by these asteroids and kind of spinning out like crazy, so let's go back in here and go to constraints on the rigid body of the ship and make sure we freeze the rotation of the player. Now if we press play again, we'll see this in action. So now our asteroid comes in, but at the moment it kind of looks a bit weird. It's just kind of frozen there. If we look at it now when it's rotating away, it looks more interesting. It's actually doing something. It looks like it's got some real feeling in the world. When it's spinning away, it kind of looks like it's actually doing something interesting. So let's add some actual spin to the asteroid as it comes towards our player. That'll make it look a bit more interesting and a bit more active. So let's go back into Unity here, or into MonoDevelop, and we're going to give it a rotation speed. So let's go up here and set the rotation speed. We'll say public float rotate speed, like that. And then down here in our update loop, in the update here, what we're going to do is apply a rotation to the body. So basically all we're going to do is say we want our object to rotate around, our asteroid to rotate as it travels through the game. So let's go back in here and we'll look at our asteroid itself. And the way we want to check and see how do we want it to rotate. So we have the 3 different axes here on our transform. So if we were to rotate it on the x-axis, we would end up, oh, it looks like our ship, our asteroid, if we zoom in on it here, is rotating this kind of way. It's flipping over like this. That's not how we want it to rotate. That's not going to be very good. So we'll set that back to 0. On the y-axis, if we rotate it, it's flipping side to side. That again is no good. So it must be on the z-axis. We can see our asteroid that way is floating and spinning around. So perfect. That's exactly what we wanted to do. Let's undo that. And we'll go back into MonoDevelop. So we know that we want to make it rotate around the z-axis. So you might think, okay, well, let's set our transform.rotation to be equal to a new vector 3 and say we don't want it to change on the rotation on the x-axis, so we'll leave that at 0. We don't want it to change on the y-axis, so we'll leave that at 0. And maybe what we should do to apply this rotate speed is we could take whatever our current rotation is on the z-axis, so transform.rotation.z, and say, okay, just add on our rotation speed. Now we know previously when we've added on a rotate speed or any kind of speed to our movement, we've had to multiply that by time.delta time so that we're making it be consistent the whole time as we go. So we'll multiply that by time.delta time. And you would look at that and go, okay, that makes logical sense. There's no problem with that. So we'll save that, go back into Unity, and suddenly we get this error down here that says we can't convert a vector tree to a quaternion. So if you've never encountered quaternions, quaternions are how you represent rotations in a 3D space. And they're really kind of complicated things to wrap your head around if you've never encountered them before. So having to work out how to set a quaternion is kind of a complicated procedure and really kind of counterintuitive. So if you were to go here, what we'd actually need to do is, if we want to set a transform rotation, we need to set a new quaternion which has 4 values, not just an x, y, and z. It has a x, y, z, and a w value, which is, we could start trying to work that out, but all we're going to do is give ourselves a huge headache. What we can do instead is, I'm going to leave this bit of code here for the moment. We're going to get rid of this new vector tree. What we're going to do is say this transform.rotation will be equal to a quaternion dot Euler. And what Euler does, it looks like it might be pronounced Euler, but it's actually pronounced Euler. What this does, it converts a normal vector tree, so an x, y, and a z value, into a quaternion. So we don't have to deal with the complicated maths ourselves of how to work out where this rotation should be in a 3D space. Very simply, we can say quaternion.Euler should be a vector tree, and we can just give in the 3 vector tree values that we want to use. So that's our x, y, and our z values. So we can just say, okay, on our x-axis, like you said, we want to keep that at 0. We want to keep the y at 0. And now we can take what is currently in our transform.rotation.z and add on our rotation speed multiplied by our time.delta time. But because quaternions are different, we can't just access the transform.rotation.z. That won't actually be what is reflected here in Unity. I mean, it would make sense for it to work that way, but unfortunately it doesn't. But what we can do instead is say we want to access the quaternion rotation, but we'll access the Euler version of it. So we can say transform.rotation.EulerAngles.z. So that'll give us exactly the z that we see here, and then we can just add on our rotation speed and our time.delta time. So all of that is to say that quaternions are really kind of a complicated maths thing to wrap your head around if you haven't looked at them before, but we can just completely avoid them and just use Euler angles and Euler here to say, okay, we just want to deal with it as if it was a normal vector tree, so we can think of it nice and simply. So now that we've written this bit of code, we can go back into the game here, let it compile, and we'll scroll down here to our basic move script, and once it's finished compiling, we'll add our rotation speed here, and we're going to set this to be, say, we'll just start out by setting it at 1 by default, and we can play around with it and see how that makes our asteroid move. So you can see at the moment it barely makes it move. It is visibly moving it if you pay really close attention to it, but that's not really very good. So let's pop it up to, nope, not 455, just 45. And now we should see, there we go. That's a more reasonable speed for our asteroid to spin around as it goes. Now if we have multiple versions of these asteroids on the screen, we don't want them to all be spinning the same way. So if I was to duplicate this, and we'll put another one here, and another one here, and another one here, if they come in flying towards the player, it's going to look really weird if they're all rotating at the exact same speed. So let's randomize it just a little bit. So we'll make sure we still have a rotate speed value here, but down here, previously we've used random.range to randomize the value between two different numbers. What we're going to do here, instead of just adding on a rotate speed multiplied by time.delta time, we're going to say random.range between rotate speed divided by 2 and whatever our current rotate speed is. So it'll be somewhere between, for example, on this one, it'll be somewhere between a rotation speed of 22 and 45. So we'll just put a bracket around both of those. So we have random.range between rotate speed divided by 2 and rotate speed. Now we could say between rotate speed multiplied by 2 if we wanted to, but we'll kind of keep it within a certain amount of range. Of course, that range that it can rotate between will increase if you change the actual rotate speed of the asteroids, but that's okay. That'll be perfectly fine too. So we'll press play here, and once it gets going, we'll see our asteroids come in, and now, although they've kind of got somewhat of a similar rotation speed, they are kind of all different, and just that little bit of difference between them, even though you might not look at them and go, oh, visually, oh yeah, they're moving at completely different speeds, in your head it kind of makes sense that, hey, they're moving slightly differently, so I can feel that they're not just like the exact same object. And that kind of that little bit of a feel of difference that a player might not necessarily obviously notice actually makes a big difference to how your game feels. So now that we've got our asteroids moving and looking a bit more kind of realistic to us, let's make it so they actually do some damage to our player when they encounter him. So at the moment, all that happens is our player is flying along, and if we hit against an asteroid, he just kind of pushes it around a little bit. Sometimes we can catch it and make it spin a bit more. Obviously, that's not really what we want to happen. So what we're going to do first of all is make it so that our player can't actually push these asteroids around at all. And to do that, we'll just change it so that our asteroids, I'm actually going to delete the other 3 because we don't need to worry about them. We'll just stick with 1 for now. So this one asteroid, we're going to make it so that it's a trigger so that our player can't actually interact with it in any way. But now that it's a trigger, our player can enter into it and we can do some scripting to make it do damage to the player. And basically what we're going to make it do is, if our player runs into the object, our player will blow up. So to do that, we're going to create a new script, a new C# script that we'll call hurt player, like that. We'll let that open up, and of course we're going to want a way for either our player to know that it's entering an asteroid, or for our asteroid to know that it's being hit by a player. And since this is a hurt player script, we're going to attach this to the asteroid, so we're going to need our asteroid to know that it's encountering with a player. So the player, we're going to give it the tag of player, one of the default built-in tags into Unity. We'll just apply that to the player there like that. Then we'll go back to our asteroid. We're going to give our asteroid the hurt player script, and now we're going to go and have a look at that script in mono develop here. So our hurt player script is going to be nice and simple and straightforward. There's not going to be too much to it. All it's going to do is basically detect if the player has entered the trigger zone. So what we do is say void on trigger enter 2D, and by default we'll say check what the other collider is. So we have our on trigger enter 2D, and we've used that previously for when say for example the ball has entered the kill zone at the bottom of the screen. We've used it to check, okay, if we've entered that zone. But what we're doing here is the zone is actually attached to the same object this script is, and we're checking for the player entering it. And it works both ways. So we don't have to worry about like, oh, we're not actually going into a zone here, we're waiting for the player to enter our zone. So do we have to do anything different? No, we don't have to worry about that at all. We can just treat it in the exact kind of same way. So here we can just say if other dot GameObject.tag is equal to player. All we want to do is very straightforwardly destroy the player. So destroy GameObject. And that's it. That's all we want to do. Nice and simple, nice and straightforward. We can save that, go back into the game, let it compile, and because we've already attached it to our asteroid, we know it should be all hooked up and working for us. So we can hit play. And now if we fly into the asteroid, boop. Oh, wait. I just realized we don't want to just destroy our asteroid. We actually want to destroy our player. So destroy game object will just destroy the asteroid itself. But of course what we want to do is destroy other.gameObject. Now we might want our asteroid to be destroyed at the exact same time, but for now we'll just stick with we're trying to destroy the player, not the asteroid itself. So we'll let that compile again. But you can see the code was working the way we intended it to. It just decided we had forgotten to destroy the correct object. So we'll hit play again. And this time we fly into it. Boom! Our ship gets destroyed and the asteroid keeps flying on through the game. So there we go. Now we can start hurting the player. So let's give a way for the player to fight back. It might not necessarily work against these asteroids, but if we're going to start adding some enemies, we're going to want a way for our player to be able to take care of them rather than worrying about our enemies just running into the player himself.